For this lecture, you need to pull out your periodic table. The periodic table is one of the most important tools a chemist has, and so today we're going to look a little bit further at the periodic table. To begin with, we have columns and rows. These columns are more important. They're also called families or groups, and the idea is each of these families shares certain properties. For instance, this group right here, lithium and sodium, if you take lithium, it's just a chunk of lithium, and you throw it into water, you get a very nice explosion. And all of them share that same property. Magnesium and calcium, they're going to act very similar as salts. And so these columns are going to be very helpful as we're learning about the elements. And then these rows also are going to tell us certain things about it. But mainly the families, just know that within a family, they typically share characteristics the same way as your family might share a characteristic, whether it be a home address or eye color or something. So to begin with, each box that you see on here is a different element. I have put carbon up here for you. Carbon, the element name is written, and then we see 6 where it has 6 protons. The symbol is a C for carbon, and then we have our average atomic mass. This is not just the mass of a single carbon, it's what the average atomic mass would be for all of the carbons in the universe. So when we're looking at this, what we can learn is that carbon has an atomic number of 6, and that always equals the number of protons. So whatever your atomic number is, that is also always equal to the number of protons. And if this is a neutral atom, which for today's lecture we're going to assume everything's going to be neutral, that protons equals the number of electrons. Why is that? Well, your protons, as we've learned before, are positively charged. And if it is a neutral atom, if you have 6 pluses, you need 6 negatives to balance them out. And your electrons are negative, and so they're always equal. Then we can look at the mass. And the mass will tell us approximately how many neutrons. So if we assume that the average carbon is probably going to have a mass of around 12, 12 minus 6 gives us 6. So every carbon atom approximately has 6 of our neutrons, because 6 plus 6 will give us 12. If it were carbon 13, then carbon 13 would have 7 neutrons, because 13 minus 6 gives us 7. So now pull out your periodic table. We're going to do a lot of these for practice. The first element I want us to look at is going to be in group 2. So when you number your periodic table, it's group 1, group 2, and then often it's group 3, 4, 5, 6, 7, and 8. Alternatively, you'll see it as 13, 14, 15, 16, 17, and 18. Either way, the 3, 4, 5, 6, 7, and 8 are very important. So I recommend writing those numbers above those columns right now. Then let's look at calcium. Calcium is a fun example. So Ca is our symbol for calcium. Above the calcium, we will see a little number. That is 20. And below calcium, we will see a number of 40.078. And that is grams per mole, which we'll find out more about what that means later. All right, so 40.78. So remember, this is our atomic number, which also equals our number of protons, which also equals, because it's neutral, our number of electrons. All right, if we have 20 protons and our mass is approximately 40, 40 minus 20 gives us 20 neutrons. So an average calcium atom would have 20 protons, 20 electrons, and 20 neutrons. Let's try another one. How about we go with a little bigger of a one? Let's go with Sn, which is 10. 10, if you find it on the periodic table, it is located right over here in group 1, 2, 3, 4, 10. It has a 50 above it and a 118, so 118.71 below it. So that's the average mass. Let's assume that's approximately equal to 119. Let's round it up for this example. We'll learn about isotopes in another video, but this is just for the average atom. So we'll learn why we round and where this number comes from later. All right, so 50, that's our atomic. So at this point my microphone dropped out, so I apologize. Hopefully I can get through my technical difficulties, but what I want you to see is that the number on top is your protons and your electrons, and the number on the bottom is going to be your mass. And so 119 minus 50 in this case is going to give us our 69 neutrons. And so that's really important to understand how many protons, electrons, and neutrons there are present within an atom. And all of this working together will help us understand what makes an element and based on where it's at in the periodic table, and help us figure out how to react it later on.